VLSos here. This is a video lesson for computer programming, data type set. We're going to start with examples of some familiar data types. A list we'll define as a list. Lists contain elements separated by commas. 1, 1, 2, 3, 5 makes 5 elements in this list that we just defined, has a length of 5, and notice that the element 1 has been repeated. The elements in a list also have an order. Their order is very particular, and it will remain in that order the way I defined it. That can help with indexing. We also have a dictionary that can contain multiple elements. Dictionaries have squiggly brackets. Lists have square brackets. A dictionary is an association between two things. The first we call a key, and the second we call a value. So in this dictionary, we've placed one association. This dictionary has a length of 1, has the key 1 and associated with the value, which is the string 1. I can put a second thing in the dictionary, a second association, the key 2 associated with the string 2. The elements in a dictionary do not have a particular order. The dictionary would be the same if no matter what order the elements in it were in. We don't index dictionaries. We refer to the contents of the dictionary by accessing the value through the key. We have, or we could say, a short comment, these two data types have length. And there are a variety of techniques to include new elements, take away elements, and iterate through them. We have a new data type to introduce a set. We'll give an example of one and call it a set. Set it equal to a squiggly bracket. The brackets that define a set are squiggly, like a dictionary, but like a list, a set contains elements separated by commas, and this set has a length of 3. We can add things to a set. We can append the add function and add another element, like we're adding the integer 4 to this set, and we can remove elements from a set by the remove function. If 1 is in the set, it will be removed. We can take a look at our set, its type, by printing a call to the type function. And we won't just print the type, we'll print the set itself. Let's save and run to observe what we get. So we reported with the print that we have its type, it's being recognized as a set, and then it prints literally the set itself with the squiggly brackets and the 3 elements in there. Notice that it included a 4, and the 1 is not in there that we first defined because we removed it. We can iterate through a set. Do that with a for loop for item in our set, a underscore set. Print the item. I have to spell things correctly. Instead of item, it should be item to remain consistent. And we can see our 3 items. We iterated and we printed them. So sets are iterable. What makes a set different than a list, other than the brackets that are being used? Well, here it is. A set cannot contain duplicate values. We can take advantage of that fact that sets will not allow duplicate values, but it doesn't break our code to attempt to do so. So we're going to define a variable called another underscore set and make it equal to the squiggly brackets. We will put items in there and we'll attempt to duplicate it. So 1, 1, 2, 3, 5. A list allows the duplicate ones. Before we take a look at it, we will also add using the add function, a 1 to the set. So that would be the third one if it was allowed in there. And then we will print to see our set. We'll save this and run. And we can see that what got printed out was a set with the squiggly brackets. It has a length of 4. There's only a single 1 in it. The one that was attempted to add didn't get added, and the 2 that we put in there when we defined the set wasn't included. There was just 1 in there. But in attempting to define it that way and using the add function, it did not break our code to attempt to do so. It's an important feature. It can make sets useful. In a comment, attempting to add a duplicate value to a set seems to not work. If a value is added that is already there, it does not add it again. Sets can be useful, especially when processing data that may start in lists. So we're going to give an example of a simple use or making use of that feature of a set. So we're going to start with a list first. So the data is equal to an empty list, and we're going to iterate through a range of values from 0 to 10. Well, we're going to iterate 20 times. But the values that we're going to get in each iteration are going to come from the rand range function. Got it spelled correctly. From 1 to 10. And we imported a random module at the top so that we can make use of the rand range function. And then our list, our data list, we will append the number that we just got at random. And we will end our iteration there. So that'll iterate 20 times, finding 20 different numbers and putting them into a list. The size of our data list would be 20, and it would have duplicates. We would need duplicates if we were only selecting numbers 1 through 10, but doing it 20 times. And then we're going to show the user the numbers that were found. But we're not going to show it simply the data list. It would show us the numbers found, but it would also include some duplicates. What we're going to do is we're going to create a variable called found, and we're going to put our data list into the set function. We're going to turn the data list into a set type and then assign it to be found and iterate through our found. So for number in found, which is now a set, we will print a modified report, and we're going to modify it by adding some space before printing our iterating variable number, and we will deny the new line character at the end so it's printed all in one line. We're going to save and run. Well, we have to spell things correctly first. That's the rand range function, not the rand range. And we have a report of the numbers found. Observe that 2 and 4 never came up in our random selection from 1 to 10. Also, we see no duplicates. We just see a list of the numbers that were found because it is showing us a set, and all of the duplicates of the list were taken out. We can run this again. We'll typically get, out of 20 trials, almost all the numbers. 1, 2, 3, 4, 5, 6, so we have them all represented there. That won't always be the case. Here we're missing 1, and it appears to be 7. That's what you would expect with some randomness. Now you. Write a simple program that randomly chooses elements from a list of 8 different strings and adds them to a set that starts empty. Iterate until the set contains all 8 strings, then stops and reports how many iterations it took to make the full set of 8. So it's very simple to the example that we have coded here, except that you're going to allow it to iterate as much as it takes to fill up a set of all 8. That means at least one of each that was selected randomly, and then report how many iterations it took in order to get the full set.